Hi Bio1. Today we're going to start looking into the carbon cycle. That's a part of the biogeochemical cycles that we've been looking at, and your assignment for this week is to make a carbon cycle diagram of how it works within your ecosystem. So make sure that you're still working on those ecosystems and make sure that I'm getting your papers from these. First off, when we talk about this, carbon is found in all living things. In fact, organic chemistry is focused on the chemistry of carbon. We judge how productive and efficient an ecosystem is based on the carbon inside of that ecosystem. And there has been much focus over the past few years due to the correlation between the amount of carbon in the atmosphere and global climate change. So regardless of what you think of global climate change, looking at the amount of carbon in the atmosphere has been an important thing. Now, lately, this is also another thing that we look at when we study life on other planets and things like that, is we try to look and see if there's carbon there, because we know that carbon has to do with life. Now, for the start today, you see this nice picture off my wall that my husband and I took in Montana last year. So we're going to go ahead and get started with what the carbon cycle is. First off, we're going to talk about plants. So you see we have a few plants in this picture here. We've got one here and we've got one here. So plants use carbon through photosynthesis. And what photosynthesis is, let me wait for it to focus there, is plants will take in 6 CO2, and that's from the carbon that's naturally found in the atmosphere. So I'll put that up here too, up in the clouds. So photosynthesis is where plants use CO2 and water they take in from rain, and they make C6H12O6, which is sugar, and they give off 6O2 through their respiration. Now that 6O2 in their respiration we can use to breathe in. So we have this person here, and that person is going through cellular respiration. Which is where he is using the 6O2 from the atmosphere that he's breathing in from his oxygen. And he's using C6H12O6, which is sugar that he's getting from plants or from other animals. And he is actually breathing out CO2 that's going to go back into the atmosphere. And he's breathing out a little bit of water vapor that's going to go into the water cycle that we studied last week. Now, we have other things that are going through cellular respiration and putting carbon into the atmosphere as well. We have this, which is one of the biggest producers of methane. They are producing a lot of CO2. They also are allowing us to get some energy from them. The other thing is, once that cow dies, I don't have a cow skeleton picture, but I do have a dinosaur one. So once that dies, it goes through decomposition, where the carbon from that is going to enter into the atmosphere or into the soil through a process called carbonification. Now, carbonification is where we get our fossil fuels. So this is going to be where those bones are going to eventually turn into peat, into coal, and then into oil or gas. Now that is going to fuel combustion. I actually don't have any pictures of big major factories at my house, but that's what I would have used for that picture. Instead, I have engines, and actually the stuff that we burn is going to produce carbon. It's going to release carbon. So then that carbon is going to go back up into the atmosphere, into that CO2 in the atmosphere. So that's the basics of the carbon cycle. The next thing I want to talk to you is how do we apply this to our ecosystems? So I'll start right here with what I would put for my ecosystem carbon cycle. So in my ecosphere, I have learned that it's very hard to draw while holding a cell phone, so you guys will have to forgive me for the shakiness here. Okay, if this is my ecosystem, I have started with rocks or coal at the bottom. Now, if I started with coal at the bottom, sometimes you start with activated charcoal at the bottom. That will provide some energy to future parts of this. Now, above those rocks that we talked about last week, I have dirt and soil. On top of that, I might have a little pieces of leaf litter and things like that, because that's going to provide some energy as well. Now, I also have plants, because you know that we had to have at least one plant in our ecosystem. And by now, my ecosystem is already 2 weeks old, so my plants are starting to flower. And I have a bug. Nice insect there. So, the plant is going to go through photosynthesis. At night, when it goes through respiration, it's going to give out O2, which is going to allow that bug to eat, or to breathe, I mean. During the day, this plant is going through the photosynthesis, the light parts, where it is going to be releasing, or it's going to be taking in the CO2. Now, this plant, I probably should not have put that there. This plant is going to be taking in the CO2 with sunlight from outside of your thing here. It's going to make food, or C6H12O6. That is then going to go into this insect. This insect then is going to breathe out CO2 that's going to enter our atmosphere. Now we have some other things that could happen. Let's say it starts dropping leaves or part of it dies. It's going to go down into here. Also, when the bug dies, or when it goes to the bathroom, that will enter into the bottom. Now then that will go through the carbonification process eventually if we have our ecosystems last long enough, and that will go right back up to CO2 in the atmosphere. Hopefully that makes sense to everybody, and your drawings will be a little better than mine were today. Now I have a challenge question for you today. If you answered this question, you'll be able to get even more points. So, the next question is, does the carbon cycle stay the same throughout the day? Your answers to that question you can send along with your pictures of the carbon cycle in your ecosystem. I've seen a few pictures of ecosystems. I'd like to keep that coming because some of you have some very nice ones that are working really well. That's all that I've got for today. We will continue with the nitrogen cycle next week. So have a good time, everybody. I hope that you're all staying safe. You're all following your social distancing stuff. I miss you all a lot, and I hope that you're having a good day. Bye.